Okay, so in this part of the lab, we're going to explore level curves of surfaces. So the idea here is that if we have a function of two variables like f of x, y, we might want to get an idea of what it looks like by looking at level curves. And a level curve is basically a set of points that all have the same height on the surface. And so if you have done any hiking or camping and you've looked at contour maps, exactly the same idea. So one way to do this in Mathematica is to start looking at level curves by clipping the plot or slicing off the top of the plot. So let's take a look at how we could do that. So notice that this particular function keeps going, but we've sliced it off at a particular z value. And so the level curve is this circle that's visible right here at the top of this plot. Now here's a slight variant of the graph. We can take a look at this. Okay. And let's look at that surface if we slice it at z equals 2. Okay, so you can imagine really slicing through that surface at z equals 2, and there's a picture of what we get. And this is actually an ellipse. Okay, so here's a few commands that you may find very helpful. So the contour plots give us all of these kind of slices. They give us all of the level curves. And here is a one-line command in Mathematica to do that. So you can see there's our contour plot, and when those contour lines are closer together, the slope or the rate of change of the function is changing more rapidly. It's a steeper hill, so to speak. So I would recommend that you actually plot the function, plot 3D, and then take a look at the contour map and compare those to see how do they correspond to each other. And then lastly, here's a clipped version of that surface. So you can start to see why that contour plot looks the way it does.